Hello everyone, this is group assignment presentation. Our members are campus of 简国宇、谢佳蕊、杨曼、何一希. Today, we will present our study on the impacts of government expenditure on economic growth in European Union. Here is our presentation outline, which is divided into the following 6 parts.
The object of our study is assess the causal impact of specific government expenditures, includes healthcare, education, gross fixed capital formation, and the development expenditure on GDP growth, and focus on study both direct and indirect effects. The complexity in analysis is that consider the complexity of economic activities crosses different countries and time periods, and distinguish the specific impacts of each type of expenditure in both short-term and long-term on GDP. The research method is to quantify the direct effects of the 4 main expenditure categories on GDP, explore the interconnections and additive effects among these expenditure categories, and analyze how they collectively influence GDP development. The model estimation is to treat each type of expenditure as an independent explanatory variable to analyze its impact on GDP growth through regression models, and the study expected conclusion is to review the relative importance and interactions of different government expenditures in promoting economic growth, providing insights for effective fiscal policy formulation. The literature review explains key methods and tests for analyzing economic variables in panel data settings, focusing on issue of non-stationarity, cross-section dependence, and model selection through diagnostic tests. We have 2 challenges. The first challenge is that economic data analysis often presents challenges associated with non-normal distributions, requiring transformations such as logarithms and subsequent unit root tests to achieve stationarity. The second challenge is that even after such transformations, however, some variables may remain non-stationary, complicating the modeling process and requiring the use of static models rather than dynamic models such as autoregressive distributed lag models. In other words, in cases where ARDL cannot be established due to non-stationarity issues, researchers may resort to panel data models such as pooled OLS, random effects, and fixed effects. The historical method is as follows. The second generation of panel unit root tests developed by Herney and Mignon addressed the limitation of standard tests in dealing with non-stationary panel data. Philippus and So focused on dynamic panel data estimation and homogeneity testing under conditions of cross-section dependence, providing valuable insights into managed dynamic relationships in panel data, especially in economic settings where such dynamics are important but difficult to model. Bontage, Fang, and Cow further erased the analysis of fixed effect models in panel data by developing a specific Lagrange multiplier test to detect and correct for cross-sectional dependence. Together, this study highlights the importance of properly handling non-stationarity and dependence in panel data in order to make informed decisions about the economic impact of variable factors. This line of work contributes to a deeper understanding of the proprietary econometric methods that should be used when faced with complex data features in economic research.
Hello everyone, I'm He. This part is data source and sample period. The dataset comes from the World Bank. We selected economic indicator data from 27 European countries. For this economic indicator, we selected gross domestic product as the dependent variable and healthy hair education expenditure, growth factor, capital formation, and development expenditure as the independent variable of our study. About the sample period, we select data from 2000 to 2020, covering annual economic indicator data for each country over 21 years. In order to ensure the accuracy of this analysis, 2021 and 2022 with incomplete data were excluded.
Hello everyone, I am Jia Qie, and I will introduce the econometric model part for our group assignment. And to estimate the impact of government expenditure on economic growth within the European Union, we hypothesize the different parts of government expenditures will influence the economic growth, and we create the model like these pictures. And the dependent variable is the GDP. The economic growth is the gross domestic product of country I at time t. And there are four independent variables. The DE, the development expenditures of country I at time t. The EDU is the education expenditures. HC is the healthcare expenditure. And the GFCF is the gross fixed capital formation of country I at time t. And USC, the beta 0 is a constant term. And from beta 1 to beta 4 is the coefficients to be estimated. And mu I is the unobserved country-specific effects. Delta T is the unobserved time-specific effects. And we also have the error term of country I at time t. So before we estimating the model, we present the descriptive statistics, and this involves the calculating mean, median, maximum, minimum, standard deviation, skewness, and kurtosis for all the variables. And we conduct the Jacob-Barra test for normality. And then we use the Dubin-Weston statistics to checking for the serial correlation test, and which is necessitates adjustments in the estimation procedure to obtain consistent standard errors. Then, to ensure the stationarity of the data, we perform the leaving, lean, and true test to check the panel unit root test. And for the null hypothesis, there is a unit root. And for the alternative hypothesis, the unit root does not appear. And the test results guide us to whether to use the levels of first differences of the variable in our model. And there are three approaches we use to estimate the model. The first one is the POLS, the pooled ordinary least squares, and it assumes the homogeneity across cross-sections and time period. Then the Hausman tests are used to determine whether the fixed effects or random effects model is more appropriate. So the non-hypothesis is a fixed effects model is appropriate, and alternative hypothesis is a random effect model is appropriate. And here is the model we used for the fixed effects and random effects. And we use log ordinarity to test all variables. And for the fixed effects, the mu I captures the control-specific effects. And for random effects, the mu I stands another things. And last one is the diagnostic test. And we use the histogram and skewness or Katoka's measures to check the normality of residuals. And deviations from normality are noted and addressed. And to check for cross-sectional dependence in the residuals, we perform these four tests: the Brisker-Pagan LM test, the Pessara scaled LM test, bias-corrected scaled LM test, and Pessara CD test. The significant cross-sectional dependence suggests the need for further modeling adjustment.
Hello everyone. Today I will be present my analysis on the given dataset. It's about results and the discussion. Let's start with the descriptive statistics. As you can see in the table, we have calculated the skewness, process, and the general border test for each variable. Skewness of total test values indicate that our data is not normally distributed. This conclusion is further supported by the p-value. The R0 indicates the non-normality. Given the non-normality, a log transformation is necessary for our data to meet assumption of normality in further analysis. Next, we have the correlation matrix. The correlation coefficients range from -1 to 1. A value of 0 means no correlation. We can observe that there are low to moderate correlations among the variables, which suggests that there is a comparison have problems. In summary, our data needs transformation due to no normality, and the variables have weak to moderate nearly relationships. And the next one is the panel unit test. From the test, we can establish the null hypothesis is that there is a unit root, meaning the data is not stationary. And from the result, we see the p-value for DE, GFCF, and HC are not significant, as highlighted in yellow. The data indicates that these variables have unit-root test and no stationary. To address this issue, we take the first differences of all variables. The first differences are stationary, and it indicated by the simplified p-value. And move on to other selects is about the product ordinary least square random effect model and the fixed effect model. The likelihood ratio test and the Horstman test can help us to choose the best model for our data. Specifically, the p-value for the likelihood ratio test is 0, and the cross-section chi-square is also 0, suggesting that the FEM is appropriate. The Horstman test p-value is 0.02633, leading us to reject the null hypothesis and confirming the FEM is the best model. Based on this test, we conclude that the fixed effect model provides the best fit for in our study. And let's move on the final of diagnostic test. The anomaly test shows a histogram of residuals indicate a relative anomaly distribution with some deviation, and the residual cross-section dependence test results are presented in the table. And we can see the four tests has all have a significant p-values. This result suggests the presence of cross-section dependence in our panel data. Exclusions to address cross-section dependence. Avoid based estimated in our regression models. In conclusion, our diagnostic tests highlight the need for robust standard error or other techniques to account for a cross-sections dependence. That's all. Thank you.
Hello, everyone. I'm He. This part is conclusion. First, our study indicated that the government expenditure in education, healthcare development, and fixed capital formation significantly promotes economic growth. These various types of expenditure contribute to GDP growth to varying degrees, and there are notable differences between countries. This discovery underscores the critical role of government spending in stimulating economic development. And then, moving on to model selection, we conduct a rigorous comparison of the post-OLS, fixed effect, and random effect models. We opted for the factor effect models due to its strong explanatory power, as evidenced by an R-squared values of 0.970791 and a significant Hausman test result, p-value equal to 0.0233, suggesting the FE model is more appropriate than the RE model. Additionally, our analysis revealed the key statistical characteristics. For example, the skewness and kurtosis analysis shows that our distribution has long-tail characteristics. The Jack-Barry test results with a p-value of 0 indicated that all variables do not follow a normal distribution. Understanding these statistical properties is crucial for selecting the right models and conducting accurate economic analysis. However, our diagnostic test also displays a significant cross-sectional dependence in the data. This suggests that future analysis should employ a more sophisticated models to adjust standard errors and avoid biased statistical inferences. In conclusion, based on our current findings and statistical challenges present, we recommend that future research should incorporate more advanced the statistical models to delve deep into the complex dynamic relationship between the government's spending and the economic performance. That's all. Thank you.